Lituya Bay, located in the southeastern part of Alaska, may appear to be a quiet, peaceful fjord, but it has a history of terrifying and destructive power that most people don't even know about. On July 9, 1958, Lituya Bay became the site of one of the most shocking natural events ever recorded, a megatsunami that reached a mind-blowing height of 1,720 feet. To put that into perspective, that's taller than the Empire State Building, and no tsunami before or since has ever come close to matching that record. The event began with a massive landslide when an enormous chunk of rock, estimated to be around 30 million cubic yards in size, suddenly plunged into the bay. This was no ordinary landslide. The force of the rocks crashing into the water sent a powerful wave surging up and over the surrounding cliffs, creating a tsunami of catastrophic proportions. The wave tore through the narrow bay at an incredible speed, wiping out everything in its path. It was so powerful that it even stripped trees from the mountainsides, leaving behind a barren landscape where the lush forest had once stood. Despite how incredible and destructive the megatsunami was, there were only a few eyewitnesses. The most well-known of these witnesses were the people aboard the fishing boat, the Lynn, a vessel that was near the bay when the event occurred. The crew of the Lynn had a front row seat to the incredible wave as it hurtled toward the shore. They managed to survive, but the impact of the megatsunami left them in awe of nature's raw power. What happened at Lituya Bay in 1958 raises a lot of questions, some of which still don't have clear answers. How exactly did the landslide happen? Was it purely a natural event, or did human activity, such as logging or other environmental factors, contribute to the disaster? And could something like this happen again? The sheer magnitude of the megatsunami's height and its unexpected nature have led to many speculations and studies over the years, but there's still no concrete understanding of all the factors involved. As scientists continue to study Lituya Bay and its unusual geography, the mystery deepens. The bay is surrounded by steep cliffs that create a narrow, confined space. This trapped environment amplifies the force of natural events, making Lituya Bay a particularly dangerous and unstable place. The landscape, combined with the ongoing tectonic activity in the region, sets the stage for even more potential disasters in the future. Scientists have learned that the same geological forces that caused the megatsunami of 1958 are still at play today, meaning that Lituya Bay's danger has never fully passed. As we move forward, we'll dive deeper into the science behind what happened in 1958 and explore the ongoing risks that this place faces. Stay tuned as we continue this journey through one of the most fascinating and dangerous natural events in history. In order to understand the full scale of the 1958 megatsunami in Lituya Bay, we need to explore the geological forces that made it possible. The event didn't happen randomly. The bay is situated in a region with a unique and volatile combination of factors that make it prone to natural disasters, especially ones as destructive as a megatsunami. Lituya Bay is a narrow fjord, which means it's a body of water surrounded by steep, towering cliffs. The geography here is a major part of what turned a landslide into a record-breaking tsunami. When the rock slide occurred on that fateful day in July, the steep cliffs funneled the massive amount of energy from the falling debris into a concentrated area. This caused the water to rise with such force that the wave reached an unimaginable height. With nowhere for the energy to escape, the force of the water surged upward rather than spreading out over a larger area. It created a tsunami that was much more powerful than what you'd typically see in the open ocean, but what made this particular landslide so massive? For starters, the region around Lituya Bay is incredibly seismically active. The Pacific and North American tectonic plates are constantly shifting, and the pressure between them builds up over time. This ongoing movement of the Earth's crust can trigger massive earthquakes, which in turn can cause landslides. In fact, it's believed that the landslide that triggered the megatsunami was caused by a relatively small earthquake, measuring about 7.8 on the Richter scale. While not a huge earthquake by some standards, it was enough to send tons of rock crashing into the bay. The landslide itself wasn't just a random event. It was part of the complex natural forces that had been at play in the region for thousands of years. The bay's geological history is filled with tectonic activity, and its physical structure makes it prone to events like this. With steep cliffs and a narrow channel, the water in Lituya Bay is essentially trapped in a confined space. When something like a landslide occurs, the water doesn't have much room to spread out, and it ends up pushing straight up and over the cliffs, creating a catastrophic wave. Adding to the danger of the bay is the region's high level of seismic activity. Earthquakes are a regular occurrence, and while most are small, larger ones can trigger events like the landslide that led to the Megatsunami. The energy released from these earthquakes can shake loose unstable rock formations, triggering massive rock slides into the bay. This, combined with the topography of the bay itself, creates a perfect storm for disaster. Understanding the geological makeup of Lituya Bay helps explain why this megatsunami was so devastating, but it also raises important questions about future events. The forces at work here haven't gone away. In fact, they're still very much present. The same tectonic activity that triggered the 1958 disaster could cause similar events to occur again. With ongoing seismic activity in the region, Lituya Bay remains a place of concern for scientists studying the area. As we move on, we'll look at the aftermath of the Megatsunami and how scientists have studied its effects. Despite its terrifying nature, this event has provided valuable insights into the power of natural disasters and the ways we can better understand and prepare for them in the future. The aftermath of the 1958 Lituya Bay Megatsunami was both stunning and sobering. The destructive wave, which reached an unimaginable height of 1,720 feet, left an indelible mark on the landscape and offered valuable insights into the forces that shape our planet. In the hours and days following the disaster, scientists and survivors began to grasp the full scope of the devastation. The most immediate and visible effect of the megatsunami was the widespread destruction of the surrounding forest. As the wave surged up the cliffs and crashed into the mountains, it stripped trees from the slopes, leaving behind a barren and eerie landscape. The water's sheer force was so great that it uprooted massive trees and left them scattered across the bay, some of them still floating in the water long after the event. The power of the wave was undeniable, and its impact on the environment was clear. Not only were trees destroyed, but the wave also caused significant erosion along the cliffs, leaving scars on the land that are still visible today. Remarkably, the megatsunami's effects were not limited to just the surrounding environment. The local population, who lived in small villages near the bay, were lucky to escape the full force of the disaster. While there were no fatalities directly linked to the megatsunami itself, the event did cause major disruptions to local communities. The destruction of land and wildlife affected the livelihoods of those who depended on the region's natural resources for survival. Despite the isolated nature of the bay, the force of the event was felt across the surrounding area, and the cleanup and recovery process was long and difficult. One of the most fascinating aspects of the 1958 megatsunami is the fact that only a few people witnessed the event firsthand. A small number of boats were in the bay at the time, and while most were able to escape the brunt of the wave, one fisherman and his family were in a boat near the shoreline when the wave struck. Their accounts provide an eerie glimpse into the terrifying power of the disaster. As the wave hit, the water in the bay suddenly surged, and they reported seeing the mountain cliffs on either side of them disappear into a wall of water. The fisherman and his family were lucky to survive, but their experience is a vivid reminder of the destructive potential of such an event. The scientific community was quick to respond to the megatsunami, conducting studies to understand its full scope and the forces that made it possible. Researchers used a combination of eyewitness accounts, geological surveys, and data from nearby seismic stations to piece together the puzzle of what had happened. What they discovered was a rare and unusual event that, while not common, could potentially happen again. The megatsunami in Lituya Bay was not just a freak accident, but rather a reminder of the raw power that exists in Earth's geological processes. As researchers began to analyze the event, they realized that the Lituya Bay Megatsunami was unique, not only because of its extreme height, but also because of the specific conditions that made it possible. It was the perfect storm of seismic activity, topography, and geology that resulted in the massive wave. In a way, the disaster offered a rare opportunity for scientists to study how large-scale landslides and earthquakes can create such intense tsunamis, something they may not have been able to study under normal circumstances. Looking forward, scientists began to consider what the future might hold for Lituya Bay. While the region's seismic activity had been relatively stable in the years since the 1958 megatsunami, the underlying geological factors that caused the disaster are still very much in play. The Pacific and North American tectonic plates continue to shift, and the possibility of another landslide or earthquake remains a real threat. But what makes Lituya Bay particularly dangerous is its location and its ability to amplify the effects of such events. The bay's narrow, enclosed shape funnels the energy of any seismic or landslide event directly into the water, making it a potential breeding ground for another megatsunami. As we move forward in this story, it's important to consider how the Lituya Bay Megatsunami has shaped our understanding of natural disasters and the science behind them. The lessons learned from this event continue to inform the ways we study and prepare for similar events in the future, highlighting the need for more research into the dynamics of earthquakes, landslides, and tsunamis. The events of July 9th, 1958 may be long behind us, but the lessons they left us with are still very much relevant today. As we reach the conclusion of the Lituya Bay Megatsunami story, it's important to reflect on the lasting impact the event has had on both scientific research in the local area. The 1958 megatsunami was a game changer for the way we understand the power of nature and the destructive potential of tsunamis. Despite the rare and isolated circumstances of this event, it has sparked ongoing investigations into similar areas around the world, all of which have the potential to experience a similar catastrophe. One of the most significant consequences of the megatsunami was the heightened awareness it brought to the vulnerability of coastal areas that are situated near active geological zones. As a result, scientists began to study how earthquakes and landslides could trigger tsunamis in other regions with similar topographical and seismic conditions. While Lituya Bay is an extreme case, the principles of how it all unfolded have been applied to better understand tsunamis in general, especially those that might occur along the Pacific Ring of Fire, where tectonic activity is high. Although there were no fatalities directly linked to the megatsunami, the disaster highlighted the importance of early warning systems and preparedness in regions at risk for tsunamis. The speed at which the waves surged through Lituya Bay left little time for people to respond, making it clear that places with a history of seismic activity need to be on high alert. In the years following the event, efforts to improve tsunami warning systems became a priority for many coastal regions around the world. Scientists also started to look more closely at the effects of large landslides and how they could trigger waves, a crucial element in preventing or mitigating future disasters. The unique and isolated geography of Lituya Bay has also made it a focal point for geological studies. Researchers continue to study the bay and its surroundings to this day, gathering data on its ongoing seismic activity and the state of its landscape. The potential for another major landslide or earthquake is still very much a possibility, and while it may be impossible to predict exactly when or where the next catastrophic event will strike, the lessons learned from the 1958 megatsunami have paved the way for better preparedness and understanding of similar events elsewhere. What is perhaps most striking about the Lituya Bay Megatsunami is the sheer power of nature. It serves as a reminder that even in the most peaceful and remote locations, the Earth's forces are always at work, shaping and reshaping the landscape in ways we can't always predict. This disaster may have been an extreme and rare event, but it's one that serves as a warning that nothing on Earth is immune from the power of natural forces. In the years since the disaster, the memory of the megatsunami has lingered, both in the scientific community and in the local memory. It stands as a testament to nature's ability to surprise us and remind us of how little control we truly have over the forces that shape our world. Lituya Bay may seem quiet and peaceful today, but it still holds the potential for the kind of sudden, devastating event that forever alters the landscape. As we finish reflecting on the events of July 9th, 1958, it's clear that Lituya Bay continues to be a unique geological and environmental location that holds important lessons for all of us. It's a reminder that while we may not be able to control or fully predict these catastrophic events, understanding and respecting the natural world around us is essential for surviving and navigating the unpredictability of life on Earth. And who knows, perhaps one day scientists will uncover even more secrets hidden in the depths of Lituya Bay. Until then, we continue to study, learn, and prepare, taking the lessons of the past to better understand the future. The 1964 Alaska earthquake, also known as the Great Alaskan Earthquake or the Good Friday Earthquake, was a devastating natural disaster that struck Alaska on the evening of March 27, 1964. The quake occurred at 5:36 p.m. Alaska Standard Time and is remembered as one of the most powerful earthquakes ever recorded. With a magnitude of 9.2, It remains the largest earthquake in North American history and the second largest globally since modern seismography began in 1900. This disaster took place in the south-central region of Alaska, affecting numerous cities and towns, including Anchorage, Seward, and Valdez. It lasted for nearly 4.5 minutes, but the destruction that followed was catastrophic. Massive ground fissures, landslides, and collapsing buildings wreaked havoc on the area, while a series of deadly tsunamis triggered by the quake caused further devastation along the Alaskan coastline and beyond. The backstory to this earthquake involves the slow but immense pressure that had built up between two tectonic plates, the Pacific Plate and the North American Plate. Over centuries, these plates had been pushing against each other, creating enormous stress deep beneath the Earth's surface. When that pressure finally released on that Good Friday in 1964, the impact was felt far and wide, not only in Alaska, but also in places as far away as Japan and California. In the days leading up to the quake, there were no clear signs or warnings. The people of Alaska, much like the rest of the world, were caught completely off guard when the Earth began to shake violently that evening. The Alaska earthquake of 1964 was caused by the movement of the Pacific and North American tectonic plates. Alaska sits on the boundary between these two plates, which are part of the larger Pacific Ring of Fire, an area known for frequent seismic activity. For centuries, the Pacific Plate had been slowly pushing beneath the North American Plate in a process called subduction. As the plates moved, immense pressure built up where they met, and by March of 1964, that pressure was at its breaking point. On March 27th, the stress that had been accumulating beneath the Earth's crust was suddenly released, leading to the massive 9.2 magnitude earthquake. The rupture occurred about 15 miles below the surface, and it stretched across an area roughly 500 miles long and 125 miles wide. The force of the earthquake caused the ground to shake violently, and in some places, the land rose or sank by as much as 38 feet. In the first few moments of the quake, the ground motion was so intense that it made standing or walking impossible for anyone caught outside. Buildings swayed, roads cracked, and entire neighborhoods shifted as the ground beneath them heaved. As the earthquake continued for more than 4 minutes, it became clear that this was no ordinary tremor. People across Alaska were experiencing a catastrophe unlike anything they had ever seen. While the shaking was terrifying, the real damage was still to come. In the hours following the earthquake, massive aftershocks, some of them as strong as magnitude 7, continued to rattle the region, deepening the destruction. The impact of the 1964 Alaska earthquake on cities and towns was nothing short of catastrophic. Anchorage, Alaska's largest city, was hit particularly hard. Buildings that had once stood tall crumbled under the force of the earthquake. Entire sections of the city were leveled as the ground split open and buckled. In some neighborhoods, houses were ripped apart as the land beneath them shifted dramatically. The city's downtown area saw significant damage, with large structures collapsing and streets becoming impassable due to deep cracks and fissures. Seward, a small town located near the epicenter, experienced unimaginable devastation. The earthquake triggered landslides that tore through the town, and within minutes, fires broke out as fuel tanks exploded. But the worst was yet to come. Minutes after the earthquake, a massive tsunami hit the town, washing away buildings, docks, and everything in its path. The water surged through the streets, dragging debris and leaving a trail of destruction. In Valdez, another coastal town, the earthquake's impact was equally devastating. A section of the waterfront slid into the sea, taking homes and buildings with it. Valdez also faced a terrifying tsunami that swept away parts of the town. Waves as high as 200 feet hit the coastline, and residents who had survived the initial earthquake now faced the deadly power of the sea. Kodiak, located further south, also suffered from the earthquake's impact. The powerful shaking caused severe damage to the town, and within minutes, the tsunami hit, destroying homes and businesses. The water rose rapidly, submerging large areas and leaving destruction in its wake. The port, a vital part of the town's economy, was wiped out as the tsunami waves obliterated docks and boats. Beyond the immediate destruction, the earthquake also caused landslides and avalanches across Alaska's rugged terrain. Whole mountainsides collapsed, and in remote areas, entire forests were flattened. The impact was felt far beyond Alaska, with shaking reported as far away as California and Japan. The aftermath of the 1964 Alaska earthquake was as challenging as the disaster itself. The destruction was widespread, leaving thousands of people without homes, businesses in ruins, and entire communities cut off from the outside world. In Anchorage, nearly every major building had been damaged or destroyed, leaving residents to grapple with the loss of their homes, schools, and workplaces. Temporary shelters were quickly set up to house those who had been displaced, but the scale of the damage meant that recovery would take years. One of the most devastating effects of the earthquake was the destruction of infrastructure. Roads and bridges were wiped out or severely damaged, making it nearly impossible to reach some of the most affected areas. The main highway connecting Anchorage to other parts of Alaska had collapsed in many places, and in the coastal towns, the destruction of ports and harbors left communities isolated. Relief efforts were hampered by these challenges as rescuers struggled to reach those in need. The U.S. military played a crucial role in the disaster response, deploying resources to help with search and rescue operations and to deliver supplies to the hardest hit areas. Military planes and helicopters flew over remote parts of the state, dropping food, water, and medical supplies to isolated communities. Naval ships were sent to coastal towns like Valdez and Seward, where the combination of the earthquake and the tsunami had caused near total devastation. The psychological impact on the people of Alaska was profound. Many who had survived the earthquake were left traumatized by the loss of loved ones, homes, and livelihoods. The constant aftershocks, some of which were strong enough to cause further damage, kept the population in a state of fear and uncertainty for weeks after the initial earthquake. In total, more than 100 aftershocks were recorded in the first 24 hours alone, and they continued for months, adding to the already immense sense of unease. As the initial shock wore off, the long process of rebuilding began. Volunteers and relief organizations from across the country came to Alaska to help with the recovery efforts. Engineers and construction crews worked tirelessly to repair the infrastructure, rebuild homes, and restore vital services. But despite these efforts, the full recovery would take years, and some of the damage, particularly in coastal areas like Valdez, was so severe that entire communities had to be relocated. In the years following the 1964 Alaska earthquake, the state gradually rebuilt itself, but the scars of the disaster were long-lasting. The earthquake left an indelible mark, not just on the land, but on the people of Alaska, who had to adapt to the new reality of living in a region with such immense geological power. Buildings and infrastructure were redesigned to be more earthquake-resistant, and new safety protocols were developed to ensure that communities would be better prepared for future disasters. One of the most important changes that came out of the earthquake was a greater understanding of seismic activity, particularly in Alaska. Scientists from all over the world flocked to the state in the aftermath of the disaster, studying the effects of the earthquake and the tsunamis that followed. Their research led to important advances in the field of seismology, including the development of better monitoring systems that could provide early warnings of future quakes. This knowledge would go on to inform earthquake preparedness efforts not just in Alaska, but in other earthquake-prone regions around the world. For many of the survivors, the memories of March 27, 1964, never faded. The earthquake had taken lives, destroyed homes, and reshaped entire communities, but it also brought out the resilience and strength of the Alaskan people. Stories of courage, sacrifice, and solidarity became part of the collective memory as residents supported each other through the darkest hours and rebuilt their communities from the ground up. The earthquake also left a legacy of awareness and preparedness. Public education campaigns were launched to ensure that Alaskans knew how to respond in the event of another major quake. Regular drills and preparedness exercises became part of life in schools and workplaces across the state, ensuring that future generations would be ready if and when disaster struck again. In the end, the 1964 Alaska earthquake remains one of the most powerful natural disasters in U.S. history. It reshaped not just the physical landscape of Alaska, but also the mindset of its people, creating a legacy of resilience and preparedness. While the state has seen other disasters in the years since, none have left a mark quite like the Good Friday earthquake, a day that forever changed Alaska. Mount Redoubt, a towering stratovolcano in southern Alaska, stood silent for over 20 years before showing signs of an awakening in late 1989. Nestled within the Aleutian Range, this massive volcano had a history of eruptions, but its long dormancy had lulled many into a sense of security. However, beneath its seemingly tranquil exterior, forces were building that would soon make headlines across the globe. In the months leading up to the eruption, subtle shifts in the volcano's behavior caught the attention of scientists. Small but persistent earthquakes rippled through the ground, a telltale sign of magma movement deep within the earth. The frequency and intensity of these tremors gradually increased, hinting that Mount Redoubt was preparing for something significant. Steam emissions from the summit vents became more frequent, and the surrounding glaciers began to show signs of melting. The United States Geological Survey, USGS, closely monitored these changes, piecing together the clues of the impending eruption. At that time, volcanic monitoring technology was not as advanced as it is today. Instruments like seismometers and tilt meters provided critical data, but they were limited in their ability to predict the exact timing or magnitude of an eruption. This uncertainty left scientists and local residents alike in a state of constant vigilance, waiting for the inevitable. The region around Mount Redoubt, known for its rugged beauty, was home to scattered communities, small towns, and vital infrastructure. The nearby Drift River Terminal, a facility used for storing and shipping crude oil, was a major concern. Its proximity to the volcano made it highly vulnerable to the potential hazards of an eruption, such as ashfall, lahars, and pyroclastic flows. Preparations to mitigate risks were underway, but no one could predict the scale of what was to come. By early December of 1989, the seismic activity had reached a fever pitch. Earthquakes were now occurring in rapid succession, and steam plumes rose ominously from the summit. The USGS issued alerts warning of a likely eruption. Local authorities coordinated emergency plans, and residents prepared for the worst, stocking up on supplies and making evacuation plans. Despite these efforts, the sense of unease lingered. As the days ticked by, tension grew. The world turned its eyes to Alaska, captivated by the dramatic buildup of one of nature's most powerful forces. Scientists worked tirelessly to decipher the signals coming from Mount Redoubt, knowing they were witnessing a prelude to a significant geological event. The stage was set, and the volcano's long slumber was about to end in spectacular fashion. On December 14, 1989, Mount Redoubt ended its years of dormancy with a sudden and dramatic eruption. It began with a powerful explosion that sent a towering column of ash and gas spiraling nearly 10 miles into the atmosphere. This was the first in a series of eruptions that would last for months, each more unpredictable than the last. The initial eruption coated the nearby landscape in a thick layer of volcanic ash, turning daylight into a dim, gray haze. For the people living in the surrounding areas, this marked the start of a challenging and chaotic period. The ash cloud, propelled by strong winds, spread far beyond the volcano, affecting communities hundreds of miles away. Air travel, a lifeline in Alaska's vast and often remote regions, came to a standstill. Anchorage, the state's largest city, saw its airport operations severely disrupted as ash particles posed a serious threat to aircraft engines. Flights were grounded or rerouted, and travelers were left stranded. Pilots navigating the airspace faced the daunting task of avoiding the massive ash plume, which could cause catastrophic engine failure if encountered. The eruption also unleashed another dangerous phenomenon, lahars. These fast-moving torrents of volcanic mud and debris formed as the heat from this eruption melted the glaciers and snow on Mount Redoubt's summit. The lahars surged down the mountain's flanks, carving paths of destruction through valleys and waterways. One of the most notable impacts was at the Drift River Terminal, where crude oil tanks were directly in the path of these devastating flows. Emergency crews worked around the clock to protect the facility, building berms and pumping out oil to prevent a potential environmental disaster. For weeks, Mount Redoubt continued to erupt intermittently, with each event bringing new challenges. Volcanologists documented pyroclastic flows, searing avalanches of hot gas and rock that raced down the mountain at incredible speeds, obliterating everything in their path. These flows not only reshaped the terrain, but also created significant hazards for those attempting to study or manage the eruption's effects. The ongoing eruption forced many residents to evacuate their homes, leaving behind their belongings and livelihoods. Schools and businesses closed, and communities struggled to adapt to the new reality of living under the shadow of an active volcano. Emergency shelters were set up, and local governments coordinated efforts to distribute clean water and medical supplies to those in need. The ashfall contaminated water supplies, clogged machinery, and created respiratory issues, particularly for children, the elderly, and those with pre-existing health conditions. Scientists working on the ground faced immense challenges as well. The conditions were harsh, with ashfall reducing visibility to mere feet and coating their equipment in fine abrasive dust. Despite these difficulties, their efforts to monitor and study Mount Redoubt provided critical information that helped guide emergency responses and protect lives. As the eruptions continued into early 1990, it became clear that this was no ordinary volcanic event. The sheer scale and intensity of Mount Redoubt's activity captured the world's attention, highlighting both the destructive power of nature and the resilience of the communities affected. As Mount Redoubt's eruptions intensified in early 1990, the volcano unleashed some of its most powerful and dramatic displays. The ash plumes grew larger, frequently reaching altitudes of over 40,000 feet, and disrupted air travel, not just within Alaska, but across significant portions of North America. The fine volcanic ash particles carried by the wind spread as far as parts of the lower 48 states and Canada, creating a widespread environmental and logistical challenge. One of the most significant hazards during this period was the impact on aviation. Volcanic ash is notorious for its ability to cause severe damage to aircraft engines, potentially leading to in-flight engine failure. A particularly harrowing incident occurred in December 1989 when a KLM Royal Dutch Airlines flight encountered the ash cloud. The Boeing 747's engines all failed mid-flight, leaving the massive jetliner in a dangerous glide. Miraculously, after multiple attempts, the pilots managed to restart the engines, narrowly avoiding disaster. This close call underscored the critical need for real-time volcanic monitoring and prompted aviation authorities to establish better protocols for volcanic ash avoidance. Back on the ground, the lahars continued to wreak havoc. As the eruptions melted the extensive glacial ice atop Mount Redoubt, these destructive mudflows grew in size and frequency, cutting through valleys and river systems. They repeatedly threatened infrastructure like the Drift River oil terminal, where protective measures were constantly tested. Engineers and emergency crews worked tirelessly to reinforce barriers and divert flows, preventing catastrophic damage to the facility and potential oil spills into nearby ecosystems. The Drift River evacuation and safeguarding efforts became a symbol of the complex interplay between human activity and natural disasters in Alaska's rugged environment. The surrounding communities faced ongoing hardships as the eruptions dragged on. Ashfall remained a persistent problem, blanketing towns and causing widespread damage to machinery, vehicles, and buildings. The abrasive ash clogged air filters, corroded surfaces, and created long-term maintenance challenges for equipment critical to daily life in Alaska's remote regions. Residents had to wear masks and goggles to protect themselves from the health risks posed by the fine particles, which could irritate the lungs and eyes. Roads became treacherous as the ash mixed with snow and ice, creating slippery and unpredictable surfaces. In addition to the physical dangers, the eruptions brought significant psychological and economic stress. Families were displaced from their homes for extended periods, businesses suffered losses, and the cost of disaster response and recovery mounted. For many, the constant uncertainty of when the eruptions might cease added to the emotional toll. Local officials worked alongside federal agencies to coordinate relief efforts, ensuring that food, water, and medical supplies reached those most in need. Community resilience was put to the test as people banded together to support one another through the crisis. Meanwhile, scientists continued their meticulous monitoring of Mount Redoubt's activity. Advances in technology allowed volcanologists to gather data in ways that had never been possible during previous eruptions. Instruments measured everything from seismic activity and gas emissions to the rate at which glaciers were melting. The findings not only helped to inform immediate response strategies, but also contributed to the broader understanding of how stratovolcanoes like Mount Redoubt behave. This eruption became a landmark case study in volcanology, with lessons that would inform future monitoring and preparedness efforts around the world. As Mount Redoubt continued to erupt well into the spring of 1990, it became increasingly clear that this event was reshaping both the physical landscape and the lives of those who called the region home. The combination of natural destruction and human determination would leave a lasting legacy in Alaska's history. As the eruptions of Mount Redoubt gradually waned in the summer of 1990, the immediate crisis transitioned into a period of recovery and reflection. The region, once blanketed in layers of ash and scarred by the powerful lahars, began the slow process of healing. For the people who lived through this event, the eruption left not just physical marks on the landscape, but also lasting impacts on their communities, industries, and scientific understanding of volcanoes. In the aftermath, cleanup efforts became a monumental task. Entire towns had to deal with the thick layers of ash that coated homes, streets, and public spaces. Removing the ash required careful coordination as it posed significant risks to both machinery and human health. Crews used heavy equipment to scrape it away while individuals worked tirelessly to restore their properties. Water systems clogged with ash needed extensive repairs, and local governments faced the challenge of funding these efforts while ensuring the safety and well-being of their residents. The long-term environmental effects of the eruption were equally profound. The ash deposits enriched the soil in some areas, boosting plant growth in the years that followed, but they also caused significant disruption to local ecosystems. Rivers and streams choked with volcanic material, altered their courses, and disrupted fish habitats, impacting the vital salmon populations that so many Alaskans relied on for food and income. Wildlife, too, was forced to adapt to the dramatically changed landscape, and some species faced increased challenges in the immediate years after the eruption. Economically, the eruption's consequences were wide-reaching. The aviation and oil industries, both crucial to Alaska's economy, bore the brunt of the disaster. The grounding of flights during the peak of the eruptions caused financial losses for airlines and disrupted travel for thousands of passengers. The Drift River oil terminal, though saved from catastrophic destruction, required extensive repairs and operational adjustments. For many businesses in affected areas, the cost of recovery proved a significant burden. Despite the challenges, the eruption also brought important advancements in volcanic science and disaster preparedness. The data collected during Mount Redoubt's eruption became a cornerstone for understanding how volcanoes interact with glaciers, how ash plumes affect aviation, and how lahars behave in rugged terrains. This information informed future disaster response strategies, not just in Alaska, but globally, as scientists and emergency planners applied these lessons to other volcanic regions. The eruption of Mount Redoubt also highlighted the resilience of Alaskan communities. Faced with one of the most significant volcanic events of the 20th century, people came together to rebuild and support one another. From Anchorage to the small towns near the volcano's base, stories of neighborly assistance and determination emerge as reminders of the human spirit's ability to endure even the most daunting challenges. By the end of 1990, Mount Redoubt had largely quieted, leaving behind a transformed landscape and a wealth of scientific knowledge. While the volcano remains active and continues to be monitored to this day, the events of 1989 and 1990 stand as a testament to the incredible power of nature and the resilience of those who face its wrath. The legacy of Mount Redoubt's eruption lives on, not just in the memories of those who experienced it, but in the advancements it spurred in science, safety, and preparedness. It remains a potent reminder of the unpredictable and awe-inspiring forces that shape our planet, challenging us to learn, adapt, and respect the natural world.